Section 4.1 Higher order derivatives, concavity and the second derivative test. In this section, we will find the second derivative of a function, determine the concavity of a function, locate the points of inflection of a function by hand and by using a graphing calculator. Higher order the derivative notation. As we know y as a f of x, the first derivative, we use the notation y prime or f prime. For the second order or the second derivative, we add another prime. So we call y double prime or y dashes for the second derivative, or f double prime, or y superscript parenthesis 2, or d2y by dx2, or f subscript with the two x's as the derivative with respect to x twice, or d as an operator, subscript x, and the superscript 2 to tell you that this is the operator differential if derivative of the y with respect to x and do it twice. Note that the notation d2y dx squared, that means the second derivative of the y with respect to x, or find the derivative twice with respect to x. The expression d by dx itself is called the operator, and it doesn't have the meaning. It has to have the function as the input with the operator to make more sense that this is the derivative of the y with respect to x. And the notation as the d by dx, dy by dx is the first derivative. Find another derivative to the first derivative. This is the second derivative. And the notation d2y by dx2 is from the derivative of the dy by dx. Example 1. Find both the first and the second derivative of the function. The first derivative is f prime of x. Second derivative is f double prime of x. As f of x equals x to the third minus 12x plus 1, the first derivative, or f prime of x equals 3x squared minus 12 from applying the power rule. The second derivative, f double prime, is 6x. The second example, find dy by dx and d2y dx squared. So dy by dx, this is the first derivative. And the d2y dx2 is the second derivative. For the function y equals square root of x squared plus 1, we rewrite it as x squared plus 1 raised to the power 1 half. And to find dy by dx, or the first derivative, that means we find the derivative with respect to x of the expression x squared plus 1 to the power 1 half. Apply the chain rule, 1 half, or the general power rule, 1 half x squared plus 1 to the power 1 half minus 1 multiplied by the derivative of the inner function x squared plus 1. The derivative of the inner function gives you 2x. Simplify more. So we have 1 half x squared plus 1 to the power negative 1 half multiplied by 2x. 2 and 2 cancel. Now we have x multiplied by x squared plus 1 to the power negative 1 half as a first derivative. Next, we find the second derivative, or d2y dx2, which is the derivative with respect to x of the first derivative, or the derivative of the expression x times x squared plus 1 to the power negative 1 half, that what we just obtained from finding the first derivative. As you notice, this is the product form, or you can think about this as the quotient form, but you have to adjust the negative exponent to be positive exponent. But let's keep it in this form and treat it as the product of the two functions. We're going to apply the product rule. So from dy by dx as x times x squared plus 1 to the power negative 1 half and find the derivative, which is the second derivative. Using the product rule, let's treat the first function as a u and the second function as a v. On the side work, u equals x and v equals x squared plus 1 to the power negative 1/2. The u prime is 1. The v prime is, which is the derivative of this expression or the composite function. Apply another general power rule to be negative 1/2 x squared plus 1 to the power negative 3/2 multiplied by 2x. Simplify to get negative x times x squared plus 1 to the power negative 3/2. Use the product rule, which is u times v prime plus u prime times v. The u is x, the v prime is negative x times x squared plus 1 to the power negative 3/2 plus the u prime, which is 1, multiplied by v, which is x squared plus 1 to the power negative 1/2. Simplify more. We have negative x squared multiplied by x squared plus 1 to the power 3/2 plus x squared plus 1 to the power negative 1/2. As we see the common factor x squared plus 1, but raised to the power negative 3/2 and negative 1/2, we're going to factor the lowest power out, which is the power negative 3/2. So x squared plus 1 to the power negative 3/2, leave the first term as negative x squared. And the second term, negative 1/2, is the same as negative 3/2 plus 2/2. So we take negative 3/2 out, still remain the power 2/2, which is the power 1, or x squared plus 1. And then, as you see, negative x squared plus x squared, they are canceled and becomes 1. Therefore, the second derivative of this function, or the y double prime, or the d2y dx squared here, is the quantity x squared plus 1 to the power negative 3/2. And we write it as the positive power to be 1 over x squared plus 1 to the power 3/2.